3 now, and we're going to be talking about decimals today. Now, maybe you're looking at the word decimals and thinking, this looks kind of familiar. Yeah, probably because we went over some basic decimals in grade 4. But because everybody forgets stuff, we're going to go over the basics again and add some new stuff. So the first thing that we do is representing decimals, such as the decimal 1.56 can be shown in several ways, including the numerical standard way, which is just written right here, 1.56, in numbers. The models below will show you different ways to represent 1.56. So you could use a place value chart, where it'd be something like ones, and it's 1, and then it's a point, tens, with the th, hundreds, with the th. You can also use it using a decimal model, which is a glorified square that is divided into little squares. And sometimes they're divided into little rectangles, but that's a talk for later. Now, we can use a place value chart to show this decimal. So how are we going to do it? Well, first we locate the ones place, which is 0. There's nothing in the ones place, so we're just going to put nothing. There's nothing over here too. But honestly, we don't really need to show this part because it's kind of a given, and you could realize just by logical progression that, well, there's obviously nothing here. And what about the 10th place? Well, there's a 1. I like to put a decimal point here just to make it clear, but to each their own. The 100th place is 1 to the right of the 10th place, which is 3. And then we go on to the 1000th place, which is 7. This is how you would use a place value chart to represent or show this decimal, 0.137. Now I'm just going to put this out there. You're never going to see this place value chart in any higher grade. And by any higher grade, I mean anything that isn't grade 6 or 7. You're not going to see a place value chart. Never. Ever. Again, this is just to make sure that you know what you're doing. You're more likely to see something like this, the decimal model, which is just a glorified square divided into little squares. So how about let's do this. Use the decimal model to show 1.19. Well, there's one whole thing, so we're just going to color this entire thing in. Pretend that's colored. That is colored, guys. Yeah. Try to do a better job coloring. And then there's 1/10, which is 10/100th, which is this much. And then there's another 9/100th, which is this much. So you're more likely to see a diagram like this than a place value chart. But chances are, by the time you get to grade 9, if you're still using these diagrams, well, you're in big trouble. That's an overview of how you would represent decimals. So after we are done this overview, we're going to move on to the next section. Reminder, guys, you can take a break at any time you want. So the next section is comparing and ordering whole numbers and decimals. So it's essentially comparing numbers, decimals version. Remember comparing numbers? We did that like first chapter of grade 4. Well, now we're going to shove some decimals in there. So remember how we compared numbers in grade 4? Well, we technically used place value, but it was more of a leftmost digit thing. Now we can tell that these two numbers have the same same place value for their leftmost digit. So we move on. 5 and 5 are the same, 7 and 0 are different. 7 is bigger than 0, so this number is bigger than this number. Therefore, 57,192 is bigger than 50,999. Now, how will we do that for this? Technically, it's the same as this up here, which is just whole numbers. So decimals are very similar to whole numbers. Why? Because even though we're not directly comparing the leftmost digit, we are lining up the decimal point. And even then, when I was comparing whole numbers, I made sure that the leftmost digit, had the same place value, which means that the ones place and the ones place lined up, or the decimal points lined up. The invisible decimal points that we don't put on because whole numbers don't have anything behind it. So after we line up the decimal points, we get something like this. And we realize that the second number, 5.207, or 207, does not have a tens place. Which means that, well, the tens place is 0, and 5 for this one is obviously bigger than 0, so 54.126 is bigger than 5.207. Now we're going to do some practice problems, where we're going to use these symbols to compare each pair of numbers. Now I'm sure that by the time you're in grade 5, you know what these symbols are. So we're just going to move on. Now these two, they're both whole numbers. Now because there's no decimal to accidentally hijack and shift the places around, we only need to see if they have the same number of digits. Both of them have 4 digits. And they're both whole numbers, so we could just directly compare them by moving from left to right. Leftmost is 4 and 4, which is the same. 8 and 8 is the same. 0 and 6 are not the same. So, which one's bigger? 6. Therefore, 4,860 is bigger than 4,806. Over here, we do, in fact, have a decimal point. Now, we look at it, and we line up the decimal point. So if we line up the decimal point, we realize that 9.23, the second number, does not have a tens place. Not tenth place, the tens place. I know, it sometimes gets a little bit tongue-twisty. So the leftmost digit, which is 2 for this one, well, this one as in 23.9, and 0 for 9.23 because it doesn't have a tens digit, 2 is bigger than 0, so now over here, we get something called trailing zeros. Trailing zeros. As in trailing. Now what are those? So trailing zeros are zeros that are to the right of a decimal point and have no other non-zero digits to the right of itself. Such as this one. It's to the right of a decimal point, and there's no other digits to the right that's not a 0. And technically, you can have an infinite number of trailing zeros, and it'd be still the same number. Now, we realize that this is 2.37, and then it's 2.370. And because this 0 is a trailing zero, we could technically just take it out. So, these two numbers are equal. What about here? Well, after we line up the decimal point, we realize that, well, they line up perfectly, so we could just go from left to right. 0, 0, decimal point, and then 0, 1. 1 is bigger than 0, so the 1 with the 1, the one with the 1, is bigger. Now, we have whole numbers again. Here's the thing. These two whole numbers have a different amount of digits. And when two whole numbers have a different amount of digits, and by digits I mean the leftmost digit is not a 0. If you have a 0 here, it doesn't really matter. If they have a different number of digits and they're whole numbers, the one with the more digits is always bigger. Unless you put in negative numbers. But of course, there aren't negative numbers right now. Now here, there are two whole numbers again, and they have the same number of digits. So let's just move from left to right. 8 and 8, 0 and 0, 0 and 1. 1 is bigger than 0, the one with the 1 is bigger. Now over here, we have two numbers that look very similar. They're slightly different though, and they're both decimals. So we line up the decimal place, and they have the same amount of digits when they're lined up. And they line up perfectly. So we just go from left to right. 6 and 6, 3 and 3 are the same, and then it's 5 and 2. 5 is bigger than 2. So the one with the 5 wins. Of course, guys, it doesn't really matter if you're going from right to left, because that's not the right way to do things. Think about it. If you go from right to left, then that's like saying 21 and 19. If you're going to go from right to left, then 9 is bigger than 1, so apparently 19 is bigger than 21, which is definitely not correct. So we always go from left to right. Okay, unless we're doing addition, like actual addition, not comparing numbers. But when we compare numbers, don't go from right to left. Now over here, it's a scenario like the first question again. There's 4 digits for both of them. They're both whole numbers, so we just do the good old left to right. 1, 1, same. 5, 1. 5 is bigger than 1, so ta-da! Done. And now we're going to do some rounding. We've gone over rounding before. So it's essentially, well, if I have to say it again, it's look at value you are rounding to. Like, say, 137, and you're supposed to round to the tens. So you look at that, and then you go 1 digit to the right, and you go 1 digit to the right. That's the ones place, which is a 7. If that digit is 5 or more, 5 or bigger, such as 6, 7, 8, 9, round up. If that digit is less than 5, round down. So, here's the thing. It's a 7, which is more than 5. So you round up, and you get 140. But if it was, well, less than 5, let's say 3. I know this looks like a very awkward 3, but it was transformed from a 7, okay? Then you round down, but you don't round down to 120 because this number is between 130 and 140. So you're going to round to either 140 or 130. And since you're rounding down, you just round down to 130. Don't do 120. I've seen it happen before. It's not an enjoyable thing to see. So yeah, just don't. Now let's do some practice. Round, oh, that's a big number, 17,239,508 to the nearest million. Well, first step, look at the digit you're supposed to round to, which is million. Second step, move 1 right. So, we get 2. And 2 is smaller than 5, which means that we round down to 17 million. And yes, we just turn everything else into zeros. Except for, well, the value that is to the left of the value you're trying to round to. In this case, we don't touch the 10 million. Now, what if we do it with decimals? It's the same general idea. So it says to the nearest tenth. So we look at that, and then we move 1 to the right, which is a 9, and 9 is bigger than 5. So we round up to 39.9. Wow. So to solidify some of our knowledge, we're going to do some practice problems. Round each whole number to the indicated place value position. So over here we have 1,000. We look at the 1,000 place. We move 1 to the right. It's a 1. So 1 is less than 5. We round down, or just technically rounding down is just keeping the value in the 1,000 and not going up. So it becomes 4,293,000. Question number 2, we're rounding to million. We go 1 place value to the right, 100,000. It's a 9. 9 is bigger than 5. So we round up to 19 million. And everything else just becomes a 0. Here, we're rounding to 100. We move 1 to the right, the tens, and that's a 2. So we're rounding down because 2 is smaller than 5. That would be 12,887,300. Now when I say everything turns to zeros, it means everything to the right of the place value we're trying to round to. Question number 4, the last of the whole numbers, is, well, we're rounding to 10,000. We go 1 to the right, which is 5. And for 5, we round up. So that'd be 8,100,000, and because we're rounding up, 50,000. Now we move on to the decimals. Round each decimal to the indicated place value position. We have here ones. Now we know that the ones is, well, not to the right of the decimal place. So what do we do? Well, we just do it like normal. We ignore the decimal place, and then we just move 1 digit right. And that's a 9. So if it's a 9, then we round up, which means that it would be 433. And there will be no more decimal because we're rounding to the nearest ones. Now here, we're rounding to the nearest hundredth. Usually, by the time you get to high school, you round to the nearest hundredth. For most questions that aren't whole numbers, you round to the nearest hundredth. So we go to the hundredth, and then we move one to the right, and we realize that it's an 8. So we need to round up. That'd be 1.6, but if we round 9 up, then that'd be technically 10. But we can't exactly put 10 there, which means that we'll have to carry it over. So it'd be 1.70. Now you may be thinking, because the 0 is a trailing 0, why don't we just take it off? But it says round to the nearest hundredth. So the thing is, in math, if it asks you to round to the nearest hundredth and the hundredths place happens to have but 0, you still have to put it there to visibly show that it's a rounded number. And that it's not exact, and there's probably stuff after the 0. Even though it's, well, rounded, so there isn't. But it shows that there is stuff after the 0, when it is not rounded. Now here, we're rounding to the thousandth place. We move 1 to the right, and we get to the 10,000th place, which is a 2. And 2's, we round down. So we end up getting 10.879. And then we move on to the last question of the section, where we're rounding to the tens. The tens, not the tenths. Funny thing is, because we're rounding to the nearest tenth, and there's actually nothing in the tenth, that's the question symbol, there's nothing in the tenth, we just still treat it like normal. So we go and see, and we move 1 digit to the right, and we have a 9. So 9 means that we have to round up. And round up, well, there's nothing in the tens, so it just goes to, well, 1. And because you're rounding to the tens, you don't actually need the decimal point. I know, if you're rounding to the hundredth and there's a decimal point in the hundredth, you have to put it there. But because you're rounding in the tens and there isn't a decimal point in the tens, well, you don't actually have to put it there. Sometimes math just likes to be nitpicky. We're going to move on to a problem-solving strategy. If you guys want to take a break at any time during the video, feel free to do that. Now, we have the problem strategy. Oh, using a Venn diagram. This isn't the worst out of all problem-solving strategies. I know that I've probably said many times that I don't like it when people have to draw models and diagrams because chances are you don't have the space, the paper, or, well, the time to do so. But using a Venn diagram actually isn't that bad, because it's like using a chart, not like drawing somebody's pumpkin patch. Venn diagrams and other types of charts actually help you to organize the information, instead of just plain visualizing it when you could just use multiplication or something. Of a group of people surveyed, 78 said they go to baseball games, and 56 said they go to cricket games. If you guys don't know what cricket is, it's kind of similar to baseball, but it's more played in Britain and India, so I'm not sure about Australia though. Anyhow, 14 of the people said they go to both. How many people said they go to baseball games but not cricket games? Okay. Step 1, understand what facts do you know. We know how many people went to baseball games and how many people went to cricket games. So 78 B, 56 C, And then 14 people said they go to both. 14 of these people said they go to both. So, how do we make a Venn diagram? Well, first we draw the two circles of the Venn diagram, because that's what Venn diagrams look like. And then we put 14 in the overlapping region, because 14 people in both groups said that they go to both. Now what would we do about this one? Well, first we need to label it. So this one would be cricket, and this one's going to be baseball. Now how do we figure out the amount of people that only went to cricket games? Well, 56 people went to cricket games, but 14 of them also go to baseball games. So the people that only go to cricket games are, well, here's the equation. People that go to only cricket games plus people that go to cricket and baseball games equals total number of people that go to cricket games, or 56. So people that only go to cricket games plus 14 equals to 56. Which means that this region is equal to 56 minus 14, which is, well, 42. But what's the question asking us? They're asking us about the baseball side. So we're going to have to do it again on the baseball side. So we know that it's people that go to baseball and cricket games plus people that only go to baseball games equals to 78. So which means 14 plus people that only go to, well, baseball games equals to 78. Which means that people that only go to baseball games equals to 78 minus 14, which is 64. That was a mouthful. So the answer to the question is 64 people say that they go to baseball games but not cricket games. Now, is the solution reasonable? Look back at the problem. Have you answered the question? Yes. How can we check our answer? Well, we could just run it through logic again. 64 plus 14 equals to 78. Now, look back at the problem, see if we got our facts straight. 78 said they go to baseball games, 56 said they go to cricket games, 14 of the people said they go to both. Well, we got that right. So, we're done checking the question. And now we're going to do a practice problem. Yes, a singular practice problem. I know, right? Of 67 pet owners surveyed, 54 have a dog and 31 have a cat. 18 people have both a cat and a dog. How many of the pet owners have only dogs? Well, here's a Venn diagram. The middle is 18. This circle over here is 54. And this circle over here is 31. So if this is 31, then that means that this is 31 minus 18, which is, well, 13. And over here, if this is 54, then this bit means, well, it's just 54 minus 18, and that would be 36. Now, since this is the dog side and this is the cat side, how many of the pet owners have only dogs? Well, this would be the only dog lobe, which is 36. 36 pet owners have only dogs. Now we're going to move on to the next section. Remember, guys, you can take a break at any time you want. finding sums and differences. Oh my. This is just like normal estimation. Except there's two, which is front-end estimation and rounding. Front-end estimation is, well, you look at the digit in the greatest place and just add or subtract. It's kind of very. It has the ability to go completely and utterly wrong at times. So I don't really like this one, but I'm still going to show it to you. So you just go to the greatest digit, well, leftmost digit, of each number, and then round to that. So here you'd be rounding down to 3, and here you'd be, well, it's a 7, so you're rounding up to 20. 20 minus 3 equals to 17. But then there's the estimation. Technically, they're both estimation or rounding. They're both a different type of rounding. This type of rounding goes for the leftmost digit of the smaller number. So the smaller number, the leftmost digit is the ones. So we're going to round everything to the ones. So here it's going to be rounded to 18, and here it's going to be rounded to 3. So that would be 15. Now what's the exact answer? Well, the exact answer is 14.4. Now 15 is closer to 14.4 than, well, 17. So usually you would want to go with, well, not front-end estimation, because there's a higher threshold for messing everything up. Now we're just gonna do some front-end estimation, even though I'm not really happy with the way that you do it, but, well, so this one, you round, and then it becomes 6 plus 2, which is equal to 8. And then here, you round this, and then that would be 100, because the front digit is 1. Well, not 1. It is 1, but it's in the hundredths place. So then you move on to the tens place. The tens place is a 0, which is less than 5, so you round down to 100. And here, the leftmost digit is a 1. You round by looking at the ones place. And the ones place is a 9, which is bigger than 5. So that'd be rounding up. And we get $80, approximately. Here, we have another one like this, front end. 5, you move to the digit to the right. That's a 1, and 1's smaller than 5, so you round down. And then here, you move 1 to the right. It's a 5. You round up because 5 is 5 or bigger. So you go to 2, and that becomes 3. Over here, it's front end, and that would make 1. You move to the right, that's 2. 2 is smaller than 5, so you round down, that's just 10.00. Technically, you could just omit those, but we're going to keep those for the sake of it. Here, you move 1 to the right, and that's a 7. And then 7 is bigger than 5, so you round up. And then you add them, because that's what they tell us to do over here. And the answer is 60, approximately. Finally, we're at the last question of, well, front-end estimation. So we get these two are the front ends. We move 1 to the right, it's a 5, we round up, 30. And then here, we move 1 to the right, it's an 8, we round up to 8. And then we add them, and we get 38. Try to write stuff using print in math. Don't use cursive. Or at least try not to, because most places prefer it if you use print. Anyhow, we're going to move on to normal rounding now. So we look at which one has, well, lesser digits, because this is whole numbers. But technically, we look at the one that's just lesser in general. So this one's smaller, and its leftmost digit is in the hundreds place. So we're going to round to the hundreds for both of them. Here we have, well, we move one to the right, it's a 5. So we round up because it's a 5. And we get 700. And here we're going to round, I'm not sure, because we haven't gone to the right yet. We're going to go to the right, it's an 8. 8, we have to round up. So that's, oh. And then we just add, like normal. And we get 3,300. So that was our first rounding thing. And here's another version in subtraction. Now, the lesser number is, well, in the hundreds, so we're still rounding to the hundreds. And here we have, move one to the right, it's a 0, we round down, 1,100. And here we have, move one to the right, a 7, so we round up, and we get 700. The answer is approximately 400. Now, if you actually want to figure it out without rounding, you would find that it's actually pretty close to 400. Here we have, oh, it's a monetary value, which means that it's relating to money. But we know that there's only 100 cents in a dollar, so why is there a thousands place? Well, sometimes this just happens when you're doing calculations for things such as taxes. And usually we have to round for that, but for the sake of this, we're just going to move on to the actual rounding. Now, the lesser value out of these two is this one. And its leftmost digit, or, well, most valued digit, very important digit, VID, is the ones place. So we're going to round to the ones place for both of them. Here, we move one to the right. It's a 2, which means that we are going to have to round down. So it's just 76. And then we add. Over here, we're going to round to the ones. We move 1 to the right, and we realize it's an 8, so we have to round up. But because if we round up, then we have to round 9 up, which would just be 10. So that's 76 plus 10, which is 86. Now here we have 65.9 and 4.1. So 4.1's smaller, the lesser value. And we're going to be rounding to the ones because 4.1, the biggest value that it has, is a 1. Here, we move on to the right, and then we get 66 minus, to the right, we round, it's a 1, we have to round down, so we get 4. 66 minus 4 is 62. This means that 65.9 minus 4.1 is approximately 62. Now over here, 51.83, and then there's 7.5, and 7.5 smaller, so we're going to round according to that one. We're rounding to the ones again. So for 51.83, we move 1 to the right, it's an 8. We round up, so that's 52, minus 7.5, well, if we're going to round to the ones, we're going to look at the tens. It's a 5, so we're going to round up. 52 minus 8 is what we round to, so that's 44. Now the next section is another problem-solving thing, but if you want to pause the video, you can do so whenever you want. Remember, take a break whenever you want, eat some snacks, go to the bathroom, do some practice problems, do whatever you do during breaks. Problem-solving investigation. Use estimation. So sometimes you don't actually need an exact value, so you just estimate. The Fernandez, I hope I pronounced that correctly, family is keeping a chart of how much weight their new kitten gains each week. Look at the chart and estimate how much total weight the kitten has gained in the first 6 weeks. Week 1, weight gained in pounds is 1.09. Week 2, 1.3. Week 3, that was slow, 0.3. Week 4, 2.03. Oh, okay. They just had a growth spurt. Week 5, 0.75. Week 6, 1.90. So what facts do we know? We know the amount of weight that they gained in each week. So what do we need to find? We need to find an approximate total weight of how much the kitten has gained in these 6 weeks, or well, the first 6 weeks, but these 6 weeks are the ones that we get. Step 2, plan. You don't need an exact answer, so we're just going to round all the values. Now, what should we round to? Personally, I think rounding to the tens would be better, but some people might want to round to the ones. If we round to the tens, we get, this one's already in the tens, so we don't need to round. This one's also already in the tens. And this one, well, the hundreds is a 0, so. Here we have 7, 5, 5 rounds up, so that'd be 0.8. Here 3 rounds down, that'd just be 2.0. Here 9 rounds up, 1.1. Which we get after we add them all up. It's the kitten gained about 7.4 pounds in the first 6 weeks. If you want to round to a whole number though, you get 1, 1, 0, 2, 1, 2. And that's 7 pounds. So, close enough. They're both pretty close to each other. But we did chop off a whole 0.3, so I would say that 7.4 pounds is a reasonable answer. Now check, did we round everything correctly? Yes, we did. We also rounded it to another more coarse value. So, and it's, well, reasonably similar, so our answer should be correct. So we're going to move down and do some good old practice problems. Michelle earned the following amounts in her job last week. $24.57 or $24.57, $8.89, and $18.24. About how much did Michelle earn? So what do we know? We know the amounts that she earned. What is our plan? We can estimate. Now we're going to solve. So usually for money, you want to estimate to the nearest dollar. So to estimate to the nearest dollar, which is in the ones place, we have to look at the tens place. Now the tens place is a 5, so 5, we round up, that'd be 25. Over here it's an 8, so we round up, that'd be 9. And then over here it's 18.24, the tens place is a 2, so we round down, that'd be 18. And once we add these all together, we get that Michelle earned around $52. A squiggly equal sign is, well, around. Now we move on to the next question, which is also the last question in this section. George volunteers at the senior center on weekends. How nice of him. During the last 5 weekends, he has volunteered for 2.5 hours, 3.8 hours, 3.1 hours, 0.8 hours, and 1.5 hours. For about how long has George volunteered in the last 5 weekends? What do we know? Well, we know the amount of hours he volunteered in each weekend. With our plan, well, we're going to estimate. And here, we can't really estimate to anything except for the nearest hour. Now let's do that. Now we have 2.5 hours, 3.8 hours, 3.1, 0.8, and 1.5. The thing is, if you have a lot of 0.5s, then you are going to overestimate by a lot. This would be 3, this would be 4 because 8 is in the tens place, which means you round up. This would be 3, this would be 1, and this would be 2. Now you can see that most of them, for this question, you rounded up, which means that we are going to have an answer that isn't that accurate. Because if you round everything up or everything down, you're going to miss or add on extra stuff. Now if we add all these together, we get 13 hours, approximate. But if you actually add everything up, you realize that it's not 13 hours. Instead, it's 11.7 hours. 11.7 and 13 are a little bit different. Now remember, guys, you can take a break. Do a break? Pretty sure there's a language out there that says that. But you can take a break at any time you want. Now the next section is adding and subtracting decimals without rounding. It's like adding and subtracting anything else, except instead of lining up the rightmost digit, you just line up the decimal point. Now step 1, you line up the decimal points. And you may have to write an equivalent decimal, but honestly, you don't. Just ignore this. I know that some of you may think that it is better to add a 0 here because then you could remind yourself that that's a 0. Do you really need to remind yourself that that's a 0? I mean, if it isn't there, if it doesn't exist, then chances are you're going to ignore it anyways. So you don't really actually need to put the equivalent decimal. Now you can see the decimal points are lined up here. So step 2, so you just add, like normal addition. 6 plus 3 plus nothing. So it's just 6 plus 3. 9. 7 plus 9 plus 4 is equal to 20. And then you regroup. And then 2 plus 4 plus 3 plus 8 is equal to 17. You regroup again. And you get 47.09. Now step 3 is kind of extra. Because step 3 is also called don't forget the decimal point. Now I would just say don't forget, but that kind of looks a little bit ominous. Like something you'd find in a horror game. So yeah, this is step 3. Don't forget the decimal point. Just remember that you just drag the decimal point down and place it in the correct place. Please do that. if you don't place it in the correct place, you're going to end up with a completely different number. Like, say this. If you end up putting it in the wrong place, you're going to get something like 4 instead of 47, or like 470 something, both of which are not correct. So yeah, don't forget the decimal point. Now to subtract decimals, you basically do the same thing, except, well, it's subtraction. Now let's do some practice problems. Find each sum. 0.8 plus 4.9. Everything's lined up. So you just add 8 plus 9 equals to 17. You regroup, and then you add on the decimal point. 5.7. Over here we have 4.1 plus 5.9. Everything's lined up. And so we move on to step 2, which is just add. 1 plus 9 is 10, you regroup. And then 1 plus 4 plus 5 is 10 again, you regroup again. And you drag the decimal point down for step 3. And you get the answer, 10.0, or just 10. That looks like 16. Yeah, so we move on to the next 2 questions. And it's 3.87 plus 7.29. You line up all the decimal points, everything's lined up, everything's good to go. Move on to step 2. 7 plus 9 equals to 16. Regroup. 2 plus 8 plus 1 equals to, well, 11. Regroup. 3 plus 7 plus 1 equals to 11 again. Regroup, and you get 11.16. So here is an example of one where lining up the decimal points would be a little bit annoying. Because then you have this. But you just add like normal, because you've lined up the decimal points, and that's all you really need to do to start adding or subtracting. Now 6 plus nothingness equals to 6. 0 plus 3 equals to 3. 3 plus 8 equals to 11, so you regroup, and 4 plus 1 equals to 5. You add on the decimal point, 51.36. Wow. So after we're done with the addition, we're going to do some good old subtraction. Now it's the same thing. You line up the decimal points, except this time you subtract instead of add for step 2. 5 minus 3 is 2. 6 minus 3 is 3. And then you remember the decimal point, which sometimes, well, sometimes step 3 and step 2 just fuse together, because once you're used to doing it, you just add in the decimal point automatically, so automatically, like robots. Except we aren't robots. At least, well, no discrimination against robots, but usually if you're looking at this, you're not a robot. Now, 4.9 minus 2.71. And you line up the decimal point. I know it looks kind of slanted right now, but it's still at the same approximate area. You line up the decimal point. There's nothing over here. So it's a 0. Problem is, there's something down here, which means that you have to regroup. So you regroup, and this becomes 10. 10 minus 1 equals to 9. Now you might want to put a 0 here to, well, fill in the blank spot and help you visualize regrouping. But after doing it for a while, you usually get used to it enough that you don't need to put the 0. So 9, you've taken off 1, so that's 8 now. 8 minus 7 equals to 1. 4 minus 2 equals to 2. Step 3, add in the decimal point, and you get 2.19. We continue to 27.3 and 6.75. We lined up the decimal point, and it's subtraction. So we need to regroup over here again. 10 minus 5 equals to 5. And since 3 has, well, given 0 over here, 10, well, we have to borrow or regroup again. Because last time I checked, 2 minus 7 doesn't really work. At least, not in this case. So that's 12 minus 7 now. That's 5 again. And then here it's 6 minus 6, which is 0. 2 minus 0 is 2. Which leaves us with 20.55. And we're going to move on to the last of the subtraction. 61.79 minus 4.003. Why would you ever do this? But, oh yeah, higher grades are annoying. Now, over here you have a 0, so then there's a 3. 0 minus 3 doesn't work, so you regroup. You get 10 minus 3, which is 7. 9 regrouped, so it's 8 now. 8 minus 0 equals to 8. 7 minus 0 equals to 7. 1 minus 4 doesn't really work, so you regroup, and then it's 11 minus 4, which is 7. And then 6, you regrouped, so it's a 5 now. 5 minus 0 equals to 5. The answer is 57.787. 787. That's cannibalism. Anyhow, so we're going to do some last questions to make sure that everything is understood. Find each sum or difference. So this one's a difference. The decimal points are already nicely lined up for us, so we don't need to do step 1. So we just subtract. And, well, we need to regroup, but this one also needs to regroup, so we're going to regroup all the way from here. It's 15 minus 8 now, and this one you regroup, so it's 9 minus 5, and then 2 you regrouped out, so that's 1 minus nothingness, so that's 14.7. Here, it's sum, or addition. Now, you don't really need a 0 for the addition bit, because there's no regrouping for that. You just 8 plus nothingness, which is just 8. And then 4 plus 6 is 10. You regroup. 6 plus 1 plus 0 equals to 7. 5 plus 1 equals to 6. The answer is 67.08. Here, we have another addition thing. Of course, you could put a 0 here, but it's just 2 plus 7 plus nothingness. Anyways, you could just ignore it. So you don't actually need to use your ink if you're using a pen. Don't do math using a pen. Or lead if you're using a pencil. Or graphite for pencils, because technically pencils are made of graphite, not lead. Anyhow, 2 plus 7 equals to 9. 1 plus 8 plus 8 equals to 17. You regroup. 1 plus 3 plus 9 plus 0 equals to 13. You regroup again. 8 plus 2 plus 1 equals to 11. And we have to regroup. So, well, there isn't exactly anything to regroup it to, so we just drag it down. And we get 113.79. Here, it's subtraction again. And here you might want the zeros for regrouping purposes, because last time I checked, nothingness minus 5 is a negative number. And you don't really do negative numbers when you're doing stuff like this. Now, 10 minus 5, 5. This one's been regrouped, so that's 9 minus 7, 2. This one's been regrouped, so that's 7 minus 3 equals to 4. 3 minus 0 equals to 3. 1 minus nothingness equals to 1. Which means that this question is 13.425. Well, that's it for this chapter. See you next chapter.